Dear Tim and Moby, I'm watering my plant all the time and its leaves are still turning brown. What's going wrong? From Ben. Well, you could just look up the plant in a gardening book, but this is a really great opportunity to talk about scientific methods. Often, when people are trying to understand the world around them, they come across a problem they just don't know the answer to. This is where the step-by-step methods of scientific problem-solving come into play. Looks like Moby's having the same problem with his plant. The first step in scientific problem-solving is to recognize the problem. Right. The plant is dying even though it's getting water every day. Why? To solve this problem, we first need to understand what we already know. Okay, plants need water. What kind of plant is that? Fig tree, right. Now we need to make some observations about the plant. The leaves are brown and falling off, and the soil is wet and squishy. Next, we make an inference. An inference is a conclusion about our observations. From what we've observed, we could infer that Moby is watering his plant too much. Now we translate our inference into a hypothesis. Well, a hypothesis is any statement we can test with an experiment. What about fig plants should only be watered once a week? Well, sure, it's just a guess, but after our observations, at least it's an educated guess. We'll need to come up with an experiment to test this hypothesis. Here's the plan. We've got 3 healthy fig plants marked A, B, and C. They have the same type of pot, the same soil, and they're getting the same amount of sunlight, so the only variable is the amount of water they'll be getting. Plant A will not be watered at all. Plant B will be watered every day. And plant C will be watered once a week.
Notice they're only changing one thing. The only thing that they are changing is what they're trying to test. How often we water the plant, and what will the outcome be? Well, we hopefully will get a plant that grows well. And the variable they're changing is the water. The pot is the same. The soil is the same. The plant type is the same. The location is the same. The temperature inside the building is going to be the same. So we're keeping everything the same except for one variable. One variable, the controlled variable, is the amount of water that it's getting.
Here's the plan. We've got 3 healthy fig plants marked A, B, and C. They have the same type of pot, the same soil, and they're getting the same amount of sunlight, so the only variable is the amount of water they'll be getting. Plant A will not be watered at all. Plant B will be watered every day. And plant C will be watered once a week. We'll check back in a month to see what's happened. Well, it's been a month and I'm still wearing the same shirt. Let's record some new observations. Plant A doesn't look too good. B doesn't look so hot either. Whoa there, plant C is doing alright. Time to analyze our data. Based on this experiment and our observations, it looks like the fig plant did best when it was only watered once a week. From that, we can conclude that fig plants grow best when they're watered once a week. Now we get to tell other people about our results and spread the word that fig plants only need watering once a week. Well, yeah, to be really sure, we should repeat this experiment several times, just to rule out accidents and variables that we may have forgotten to consider. But you get the point. Using scientific methods can help you be right more often, and not just in science class. You just have to make sure you do all the steps. If you form a hypothesis without making any observations, then you really are just guessing. And you'll never know if your hypothesis is true or not without testing it with an experiment.
See how we do on a quiz. What is the first step in the scientific problem solving? Analyze your data, form a hypothesis, or recognize the problem. Try this one. Right after you recognize the problem, it's time to what? A. Observe and infer. B. Draw a conclusion. Or C. Perform an experiment. A lot of times students just want to jump right to the experiment, but you need to go and make some observations first. What is the point of doing an experiment? Is it A, to recognize a problem, B, to form a hypothesis, or C, to test a hypothesis? You said to test a hypothesis. You were correct. What are factors in an experiment that stay the same? What do we call them? Constants, variables, or coordinates that stay the same? They're called constants. If you constantly are doing something at home, that means you're always doing it every single time. What is an explanation supported by results from an experiment? Is it a law, a theory, or a hypothesis? Didn't really talk about this much in there, so what do you think? What is an explanation supported by results from an experiment? We've talked about laws and theories. Is it a hypothesis? A theory? Let's try a theory. So theory ends in Y. It tells us why we think we're seeing that. What is a control in an experiment? Control. Is it a standard used for comparison? A variable used for comparison? A switch that turns on and off? So a control is one that you are going to use for comparison. It's not a variable, it's a standard that we use for comparison. So, like if we had a plant that we didn't do anything to, we can see if the water actually is the reason for it. So a standard. What must a scientist do before he or she draws a conclusion? Is it A, record and study the data collected, B, alter the data that has been collected, or C, ignore all of the data collected? Now hopefully this one's pretty straightforward. What is a scientific law? We talked about this earlier this year. You can use your notes if you want. Is it a traffic law? A law that describes the behavior of something in nature, or a law that describes machines? Yes, B. Where can you find research materials? At the library, on the internet, or both of the above? Yes, both. What's another word for an educated guess? Is it a theory, a hypothesis, or a fact? You're right, a hypothesis.